Hi, welcome to AVM Math Hub. Today I am discussing about one mathematical problem from CSIR Net 2009 question paper from section B. The problem is, which of the following are true? Summation n is equal to 1 to infinity minus 1 whole power of n divided by n does not exist. Summation n is equal to 1 to infinity 1 by n is convergent. Third option, summation m is equal to 1 to infinity, summation n is equal to 1 to infinity 1 by m plus n whole square is convergent. Option 4, summation m is equal to 1 to infinity, summation n is equal to 1 to infinity 1 by m plus 1 whole square is divergent. Actually, this problem is in real analysis. So, let us analyze one by one. Solution. Suppose the option 1, summation n is equal to 1 to infinity minus 1 whole power of n whole divided by n does not exist. Clearly, this is in alternate this is from alternating series. See, summation n is equal to 1 to infinity minus 1 whole power of n divided by 1. This is clearly an alternating series from alternating series. Alternating series. In alternating series, we decide the convergent or divergent of alternating series by using a Leibniz test. From the Leibniz test, the statement of alternating series is if sequence un is a sequence of positive terms such that it has two properties, that is sequence un is a decreasing sequence and limit n tends to infinity un is equal to 0. So this is the statement for alternating series. Then the alternating series is that is summation n is equal to 1 to infinity minus 1 whole power of n into un is convergent. The following two properties are belongs to alternating series. The alternating series, which is these two are satisfied, then it is a convergent series. So we can compare the given series with the summation n is equal to 1 to infinity minus 1 whole power of n divided by n. So we get, after comparison, we get 1 by, suppose 1 by n into minus 1 whole power of n. 1 by n into minus 1 whole power of n. Suppose we get un, let us assume that un is equal to 1 by 1 by n. That implies we can apply limits. Limit n tends to infinity 1 by n is equal to 0. So this is the second condition of Leibniz test. This is the second condition of Leibniz test. See, and the first condition, let un is equal to 1 by n and un plus 1 is equal to 1 by n plus n. Since n plus n is always greater than n for all n belongs to n, you can write in the reciprocal of this one is 1 by n plus 1 is always less than 1 by n. That implies un plus 1 is less than un. So 1 by n plus 1 means 1 un plus 1. 1 by n means un. So un plus 1 is less than un for all n belongs to n. Therefore, this is the decreasing sequence. Sequence un is decreasing sequence. This is the decreasing sequence. So in the both the conditions of Leibniz test are satisfied. So this is the decreasing sequence, and the second condition, limit n tends to infinity un is equal to 0. So both the conditions of Leibniz test are satisfied. Therefore, according to the statement of Leibniz test, the given series is convergent. But in the given first option, limit n tends to n is equal to 1 to infinity does not exist. So the first option is wrong. So it is wrong. It does not exist. Okay. So therefore, summation n is equal to 1 to infinity minus 1 whole power of n by n is convergent, is converges. But here the first two options does not exist. So this is the wrong statement. So we'll go to the next option. Summation n is equal to 1 to infinity 1 by n is convergent. We'll check the second option. Second option. Already we know that the P test is also known as an auxiliary series, auxiliary test, or also it is known as hyperharmonic series. P test is also known as auxiliary series and also known as hyperharmonic series. In this test, the infinite series summation 1 by n power p is convergent. The statement of P test, it is a convergent when if p greater than 1, summation n is equal to 1 to infinity. Similarly, divergent if p less than or equals to 1. Now the option, option is summation n is equal to 1 to infinity 1 by n. So comparing with the p series, limit n tends to infinity 1 by n power p. So here in the given condition 1 by n power 1, comparing with the p series test, that is summation n is equal to 1 to infinity 1 by n power p. So p value 1. Here p is equal to 1. P is equal to 1. Whenever p is equal to 1, the series is divergent, and therefore the given series is divergent. Therefore it is divergent. Divergent. So in the second option, this is a convergent, so which is wrong. So second statement is also wrong. In the second statement, that is, for example, 1 by n cube, here p is equal to 3 is convergent, is convergent. Suppose 1 by nth root to n, that is equal to summation 1 by n power 3 by 2. Here p is equal to 3 by 2, which is less than 1, is also convergent. And also 1 by root n, this can be written as 1 by n power 1 by 2. Here p value, here p is equal to 1 by 2, which is less than 1. Therefore it is divergent. Therefore it is divergent. So divergent, but this is the in the option it is a convergent, so second option is also wrong. Now you'll go to the third option, that is summation n is equal to 1 to infinity, m is equal to 1 to infinity, and summation n is equal to 1 to infinity 1 by m plus n whole square is convergent. We'll check it. Third option, option 3, given that m is equal to 1 to infinity, summation n is equal to 1 to infinity 1 by m plus n whole square is a, this can be written as to splitting, put n is equal to m is equal to 1 to infinity, can split the this summation. This can be written as 1 by, put n is equal to 1, m plus 1 whole square plus 1 by m plus 2 whole square plus 1 by m plus 3 whole square plus, and so on. After split the summation, after splitting, summation m is equal to 1 to infinity 1 by, again we can splitting 1 by m plus 1 whole square plus summation m is equal to 1 to infinity 1 by m plus 2 whole square plus summation m is equal to 1 to infinity 1 by m plus 3 whole square plus, so on. Again we can split, substitute m is equal to 1, 1 by m is equal to 1, 1 plus 1 2, 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus, and so on. This is the one summation plus the another summation 1 by 3 square plus 1 by 4 square plus 1 by 5 square plus, and so on. Again another summation, put m is equal to 1, 1 plus 3 4, 4 square plus 1 by 5 square plus 1 by 6 square plus, and so on. Now this can be written as 1 by 2 square plus here 1 by, here see 1 by 3 square and one more 1 by 3, 1 by 3 square here. So we can write here 1 by 3 square in the one brackets and 1 by 4 square plus, and again 1 by 4 square plus, and again 1 by 4 square, and so on plus 1 by 5 square plus 1 by 5 square plus 1 by 5 square plus, and so on. So this can be written as summation n is equal to 1 to infinity. So no, no, no. We can write one more step, that is equal to 1 by 2 square plus 1 by 3 square plus 1 by 3 square means 2 by 3 square plus 1 2 3 4 like this 4 by 3 by 4 square plus and 4 by 5 square plus, and so on. Next we can write in the summation n is equal to 1 to infinity 1 plus 2 plus 3 plus 4, that is n by n plus 1 whole square, that is summation un. Simply we can write summation un. So therefore un is equal to n by n plus 1 square. So now to apply the limit comparison test, to take, already we know the definition of the limit statement of limit comparison test. Take un is equal to n by n square, that is equal to 1 by n, and vn is equal to 1 by n 1 by, so n 1 by n, 1 by n, whatever you take the common, that is vn. So we can take common n square, we can take n square, so n square, so it can be written as 1 plus 1 by n square, so 1 n cancel, finally 1 by n is there, so that is vn. Whatever you take the common, that is vn. So we know un and vn. Apply the summation here, summation vn is equal to summation 1 by n power 1. So this is in the form of the p series test or auxiliary series, that is equal to 1 by n power p. So here therefore p is equal to 1, p is equal to 1 in p series test. In P test summation Vn is divergent. In P series test, it is divergent. So if P is less than or equals to 1, it is divergent. If P greater than 1, it is convergent. Okay. Take Un is equal to 1 by n square. Now calculate. Now calculate limit n tends to infinity Un by Vn, that is equal to limit n tends to infinity. So now I want to apply by again limit comparison just for this series. Limit n tends to infinity. What is Un? Un means 1 by n, no? 1 Un by Vn. Un means 1 by n and Vn means 1 by n by n square. Un means here Un means n by n plus 1 square. N by n plus 1 square. Yes. Okay, right. This is the this is Un. And what is Vn? Vn means 1 by 1 by n divided by 1 by n. This can be written as n by 1. Why? Because the division of two fractions is not possible. We can convert into multiplication. That is equal to limit n tends to infinity n into n square by here we take common n square. So this can be written as 1 by 1 plus n whole square. So these two are cancelled. We can apply limit for this 1 by 1, that is equal to 1. Therefore, limit n tends to infinity Un by Vn is equal to 1. So that is not equal to 0, which is a finite number. So therefore, by limit comparison test, therefore, by limit comparison test, states that both the series summation Un and summation Vs converge or diverge together. When it is a finite number, the limit comparison test tells the given series converge or diverge together. So therefore, already we see it is a divergence. Summation Vn is also divergent. By using the nature of the series, summation Un is also divergent. But in the option 3, which is it is a convergent, so it is wrong. So option 3 is also wrong. The final is option 4. So option 4 is right. Okay. So this is the procedure. We have to solve any problem by using the given conditions, by using given options. Okay. If you have any doubts, please WhatsApp me. I will respond immediately. Thank you so much. Have a nice day. Thank you.